Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's video, we will simulate a shortcut distillation column using Aspen Plus. This is the same example which we have previously done in Aspen HYSYS once we had compared both the manual and simulation results, and now we are going to perform the same example or the same simulation or the same problem statement we are using for Aspen Plus simulation. So the problem statement is that a saturated liquid having a molar flow rate of 10 kmol per hour with a mole fraction of 0.4 for benzene and 0.6 for toluene is fed to a distillation column. From the distillate, we required 99.2 mole percent benzene, while from bottom, we required 98.6 mole percent toluene. The relative volatility value is 2.354. The reflux is returned as saturated liquid, and the column has a total condenser and a partial reboiler. We have already simulated this process using Aspen HYSYS, and today we are going to simulate the process using Aspen Plus. So before starting the video, if you have not subscribed to the channel yet, please subscribe to the channel. Click on the bell icon to get all updates related to this channel. So we will first add the components benzene and toluene. Then we will select the property package as Engg Robinson, and then we will click on run button, and once the results are available, we will go to the simulation environment and we will select, first we will go to the columns and then we will select DSTWU, which is the shortcut distillation column using Win Underwood Gilliland method. We will name it as COL, which is column, feed, 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 distillate, DISTL, and bottoms BTMS. Control A, Control B to align it. We will click on this feed, and we are not given the information about the temperature, but we are given information that it is saturated liquid. Fluid fraction is 0, pressure is 1 atm, molar flow rate is 10 kmol per hour, the mole fraction of benzene as 0.4 and toluene as 0.6. This is how we specify the feed. Then we go to this column. Out of the number of specifications, the first one is the number of stages and reflux ratio, one of these to be specified. We have studied in our previous examples that we need to specify the value in negative, because if it is greater than 0, as you can see on the screen, then it will be the desired reflux ratio. If it is less than -1, then it is the desired reflux ratio is calculated by multiplying the minimum reflux ratio with this value. We will specify it as -1.1, which shows that the minimum reflux ratio will be multiplied with this 1.1. Now we need to specify the recovery values for light key and heavy key in distillate. Remember, that is of distillate. We are confirmed, or we have a confirmation, that benzene will be light key and toluene will be heavy key. But what will be the values? For this, we have to go to the MS Excel sheet. Coming here, we will first fill it that the total flow rate is 10. Composition of benzene is 0.4, toluene is 0.6. So simply 10 multiplied by 0.4 and 10 multiplied by 0.6, and that will be 1. Now we are given the information that it is 0.992, 99.2 mole percent benzene in distillate, toluene 98.6 mole percent in bottom. So the remaining will obviously be benzene, which is 0.014 in bottoms and 0.008 for toluene in top, and the sum of these two will be 1 each. Now if we apply the material balance manually, then we get the value of flow rate of distillate as 3.95, while that of the bottom is 0.605. We will simply multiply it 3.95 into 0.992, 3.95 into 0.008, so 3.9184 and 0.0316. That are the flow rates of benzene and toluene in that distillate. Similarly, if we just simply subtract these, we get the flow rates in the bottom. So these are the values. Now this is the overall material balance, but this is on the basis of mole fraction. These are the mole fractions: 0.992, 0.008, 0.986, 0.014. But we need the value of recovery of the components in the distillate. So how we can get it? We need to divide this 3.9184 with the total value in feed. The amount of benzene in distillate divided by the amount of feed, that divided by the amount of benzene in the feed. So that is 0.9796, and similarly 0.0316 divided by 6. So that is the amount of toluene in distillate divided by the amount of toluene in the feed. Now this is the balance, or this is the recovery value which we have calculated using MS Excel. Now we will simply use these values in Aspen Plus. We will just copy paste it over here. 0.9796, 567. Pressure for condenser is 1 atm. For reboiler it is 1 atm, and the condenser type is total condenser. We will click on this run button, and once the results are available, we will go to the first stream results to check whether our required results or required specifications have been met or not. So if we look at the mole flows, 5.9684, 0.0816 as calculated, 3.9184 and 0.0316 as calculated from Excel. Going to the mole fraction, as you can see, 0.992, 0.008, and 0.986512, just going to another round of digits. But if we look at the broader picture, we get the required results in Aspen Plus. And then we will click on this column results to see the values of reflux. So minimum reflux ratio is 1.67787. The actual reflux ratio is 1.84566. The minimum number of stages are 11. The actual number of stages are 27. The feed stage 16. Number of stages above feed stage are 15. And condenser reboiler duty and the temperatures are given over here. So you can see that our Excel results and our Aspen results are matching with each other using these specifications which we have stated. So that's how we simulate the shortcut distillation column, and that's how we integrate actually the MS Excel and Aspen simulations. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video, and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.